In this segment, I want to look at a case study that is of regular expressions. These are expressions used to describe strings, or more correctly, sets of strings. So we've got 5 different kinds of regular expression, and I'm using red font to describe regular expressions, and then blue font for the strings that they match. So the string epsilon just matches the empty string. The string with the character A, the regular expression with the character A in it, matches the string with the character A in it. So far, so straightforward. Now the first compound regular expression is E bar F, and that matches a string if E matches S or F matches S. So it's an alternative. We've got 2 alternative patterns. You match E bar F if you match either E or you match F. Now, conversely, if you have the regular expression E followed by the regular expression F, a string matches that if you can split the string in half, so you can make up the string by concatenating U and V, and E matches U and F matches V. So you can split the string in half, so E matches the first half and F matches the second. So that is the second way we can form a regular expression. And the third way we can do it is to say match something repeatedly. So E star says match E 0 or more times. So matching 0 times means it matches an empty string. Otherwise, you can split a string S into n parts and E matches each of those parts. So for example, if we take the regular expression AB or BA all starred, that will match the string AB, AB, BA, it'll match AB, BA, it'll match an empty string, it'll match the string AB, but it won't match the string with just B in it, for example. Now here I'm simplifying slightly, so if I write AB or BA, that's to show that when I put 2 things together, they match, that binds more tightly than separating them by or. If you think of EF as being like multiplication and E bar F as like addition, you'll have the right sort of associativity, the right sort of matching for those expressions. So when I write I don't need to bracket the AB together. Okay, so that's an abstract definition of regular expressions. But what we're going to do is, and this is why it's in this block, is we're going to use functions to model regular expressions directly. So we're modeling each regular expression as the function which matches exactly the strings that the expression denotes. So each regular expression is itself a function. And we're saying the type regex is function from strings to Booleans. The function returns true if the regular expression matches the string. It returns false if not. So what do these look like? Well, representing epsilon is straightforward. That's the function that checks whether the string is equal to the empty string. That's straightforward. And here we're using an operator section. We're partially applying the equals operator to the string empty. In a similar way, for a given character ch, the regular expression that represents is the function that just checks whether the string is equal to the list with just ch in it. That is the string with just the character ch. So that's the function that represents the single character regular expression. So we're defining directly these functions string to bool. What about the case of alternatives? I'm using the operator bar 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 to represent the vertical bar. And so what this vertical bar does, it takes two regular expressions that are functions and returns a regular expression. So that's a function. So what's E bar 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 F? Well, it's the function that takes a string and checks to see if it matches E, that is apply E to X, checks to see if it matches F, that is apply F to X, and then take the disjunction of the result. So if it matches E or if it matches F, we'll get the answer true there. So this is combining the function E with the function F to return this new function, lambda X arrow E of X or F of X. So that's, again, you can see we're defining what sometimes is called a combinator that takes two functions and returns another function. What about concatenation, joining two strings together? Well, how does that work? E and F, again, are regular expressions, so those are functions which apply to strings, return Booleans. What we need to do is look at all the ways you can split up a string. And what I'm going to define in a second is this function splits that does that. It takes a string and returns a list of pairs of strings, which are all the ways of splitting up the strings. And then here we have a list comprehension, and it says run through all the possible splits where you say the first half is U, the second half is V. And what we do for each of those is we check whether U is a match for E and V is a match for F. So we apply E to U, gives us a Boolean, and we take the conjunction of that and F and V. So that's saying U matches E, F matches V. And what we're doing is we're taking all those possible splits, and that gives us a list of Booleans, and we just need one of those to be true. We're just looking for one way that we can make the split, and so we take the OR, which combines the whole list of Booleans together with the OR operator. So, and what we're doing is we're returning the function lambda x for a string x, split the string up in all the different ways. For each of those, work out if the two halves match E and F, and then take the disjunction. So just look for one of those splits where both of those is true. So again, we're getting a function here as a result. So it's taking two functions E and F and returning another function. Okay. Oh, and I said I'd explain how splits works. Now, one definition of splits is to define it recursively. So what are the splits of an empty list? There's just one, both halves are empty. What about the splits of a list x cons x's? Well, there is the split where you have the empty list and x cons x's. Otherwise, it's made up of a split of x's where you put x on the front of the left-hand half. So you either get a split where there's nothing on the left-hand side, or you get, in the case where there is something on the left-hand side, it must begin with x and then be followed by some split, the first half of a split of x's. Okay, that's given us concatenation. Finally, we need to think about E star. And what's quite neat about this is that we can model the recursion that there is in the definition of star in the definition that we make. So we're saying star of E as a regular expression matches either epsilon or E followed by star E. Now, we've just changed the concatenation operation we're using here is a slightly different one, because we don't want to allow E in this concatenation to match an empty string, because otherwise we go into what's called a black hole. So we use a similar definition to the previous concatenation, angle plus plus angle, except that we use F splits, which exclude the split where the first half is empty. And we do that just by composing splits with the tail function. So that gives us our final regular expression. So we've got regular expressions for concatenation of E and F. We've got regular expressions for alternatives between A and F. We've got regular expressions for epsilon and a single character. And we've got regular expression for star. And as an example, let's have a look at this, AB or A star. This is how this gets represented as a regular expression. You apply char to A and char to B and join them and have the alternative with just char of A, and then we have star of the whole thing. Let's go into VS Code and see that in practice. So here on the right hand side we're in a terminal, and we've said let the function f be this star of the example, char A or followed by char B or char A. Let's see what happens if we apply f to the empty string, for example. We get true if we apply f to a string with just A in it. We get true if we apply a string f to a string with AA in it. We get true. But if we apply f to a string with BB in it, we would get false, because that every time you match a B, the only way you can match a B is by having an A before it. So we can have, for example, AB will match, but ABBA will not. So there we can see, so what we can do with this representation is we built a representation of this, of any regular, we can build a representation of any regular expression this way, and it works as a function that tells us whether or not a string matches that regular expression. And we do that simply by applying the function, because the function takes a string and returns true or false according to whether the string is a match for the regular expression or not. Now, we could stop there, but what I want to do in the next section is look at a different way of representing regular expressions and contrast it with what we've looked at here.